Recording in progress.
Good morning, students. Good morning, students.
Good morning, sir.
Very good morning, Amma. Just inform to your friends to join to the class. So in the earlier class, we discussed about two analog modulation techniques. So that is the pulse width modulation and pulse position modulation technique. So these two topics, that is the pulse width and pulse position modulations, are one of the important topic for the next upcoming exam. And the second question from the second unit of your digital communication paper, that is paper 6. So that is the second question is on the frequency shift keying and phase shift keying. It is also one of the important topic for the upcoming examinations. So that's why today we'll discuss about a few things about the amplitude shift keying, frequency shift keying, and phase shift keying. So that is ASK, FSK, and PSK. So three important topics. The general communication, because in the analog communication, the modulated waveform added to the carrier wave, So the modulated wave is in the, that is your signal is in the form of the analog signal. So that is in the sinusoidal waveform format. So that is low frequency sinusoidal wave is added to your carrier wave. So we have various types of modulations like amplitude modulation, frequency modulation, and phase modulation. Now in here, for these modulations, that is the ASK, FSK, and PSK, here we are adding the digital data, the digital information to your carrier signal. So if we are adding the digital information to the carrier signal, then instead of the analog modulation, this is called as a digital modulation. So these three techniques are meant for the digital modulation techniques. So that is the amplitude shift keying and phase shift, frequency shift keying and phase shift keying. These three techniques are the digital modulation techniques. So for this, so these are the three different types of digital modulation techniques. That is amplitude shift keying called as ASK, frequency shift keying is FSK, phase shift keying is PSK. So this is phase. So how these will be changing? So before that, we'll see generally what is the basic principles, basic things involved in the modulation. That is whether we can able to change the carrier amplitude, or we can change the frequency of the carrier, or changing the phase of the carrier. So if we are adding the signal, the carrier, there is something deviation in the carrier wave. So the deviation, the deviated waveform, whether it is a amplitude modulated wave or frequency modulated wave or phase modulated wave, which is communicating through the media. So the basic terms are amplitude, frequency, and phase. These are the three important terms. Keeping these two terms, that is frequency and phase, only variation in the amplitude, that is called amplitude modulation. Keeping amplitude and phase are constant, frequency change in the frequency, so that is called as a frequency modulation. And keep these two things constant, that is amplitude and frequency are constant, only change in the phase, that is called as a phase modulation. So here the amplitude, generally the top point, it is called as a crest, and this one is called as trough in the sinusoidal waveform. This is generally called as the amplitude. Now negative amplitude to the positive amplitude, that is a peak to peak amplitude. So simply amplitude is constant, that is baseline to the highest value. This is generally the amplitude, that is the vertical distance between a crest and the wave's central axis amplitude. This is the general definition of your amplitude. So that is, amplitude is about the strength of the wave, of the power of wave's vibration or oscillation. So this amplitude, suppose more the amplitude, the power transmitted will be more. So therefore the amplitude will play an important role in the communication. So that is related to amplitude. So here you have, that is the greater amplitude of the wave, more energy it carries. So higher and higher energy, if you want to carry, the amplitude will be higher. Then the frequency is concerned. Suppose let us take one of the point, how many number of waves are crossing. So wave cycle, one cycle, two cycle, three cycle, divided as how many number of cycles are crossing per second. That is generally a frequency term. That is a wave cycle passes the line. So let us take one point, so which is coming like this. So this point, how many number of waves are passing through a particular line, this line. So this line, how many number of cycles are crossing. So that is within a certain time, that is within 1 second, how many number of cycles are. The number of times a wave cycle. So that is generally a frequency. So how many number of times the wave cycle repeats within a certain time. Let us assume per second, cycles per second. That is generally. So phase is concerned. So if it is a sinusoidal waveform, so in the angular representation, this part is 0 degrees angle. So here it is 0. And if it is moving like this is a 90 degrees. So that 90 degrees angle can be represented like this. So this is the highest value. So this is 0 horizontal axis, and it is going to this peak value, that is a peak here. This is a 90 degrees angle. Angular velocity is concerned. The wave is represented like this. It's 90 degrees. Then coming to this, it is 180 degrees. completely its phase. So here it is this. So up to this, it is a positive value. Up to this, it is a positive. That is from 0 to 180 degrees, it is a positive angle. Then come down, that is above 180, it is a negative angle up to 360. So that is a negative phase. So therefore, if there is any phase difference, means from positive to the negative. So this position, that is starting from here. So 0 to 180, it is positive. 180 means exactly opposite direction. That is the 180 degrees phase. So it is 180, 270, 360. So this is the angle representation of the sinusoidal wave. So the phase specifies the location of a point within a wave cycle. Okay, so therefore 90 degrees, 180 degrees, 270, 360, etc. So this is like that. So 0 or 360, 90, 180, 270, and 360, like that. So the locations on a wave cycle can be specified. So this is, let us vector. So if it is moving, starting from here, 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 so 90 degrees, then 180, then 270, then so vector is rotating like that. So then we can set the phase as an angle in either radians or degrees. So as well as in fractions of a cycle. So this can be visualized with a rotating wheel. So rotating wheel is a wheel, is this blue line which is rotating. So that blue line is coming to exactly here. The above cycle, it is upward direction, and in the below this cycle, it is in the downward. So like that. So that is the point. This is the exact point. It is 90. So here it is. This is 90 degrees. Therefore, this point is at here. So this is 360. That is 0. 360 complete. So length also, it is completed 360 degrees. Again, it is coming to the starting position. So and a spoke tracing the wave as time goes. Now coming to the actual. So information is in the digital format for the amplitude shift keying, frequency shift keying, or phase shift keying. The signal, that is the whatever the information we are going to communicate, instead of an analog format, the signal information is in the digital format. So let us assume this is the digital data. So digital data, so that is one is the 5 volts, then 0, 0, 0, 3 clock pulses 0, then 1, 1, 0, 1, 0, 0, 1. This is your digital information. If this digital information is added to your carrier wave, so instead of here, normally it is a your modulating signal is in the form of a low frequency signal. So in the analog modulation, the low frequency baseband signals, the low frequency signals are added to the carrier wave, high frequency carrier wave. So here the digital signal directly added to the carrier wave, like this. Okay, this is your digital input. So digital input is added to the carrier signal. Then when it is the carrier wave, we will use to send these digital signals. Now in the amplitude modulation, let us assume if it is an amplitude modulation, that is amplitude shift keying, it is called as amplitude shift. Instead of modulation, we are calling it as a keying, shift keying. So in the suppose amplitude shift keying, if we are using the technology amplitude shift keying, if there is a positive, the carrier wave will be present. For 0 signals, the carrier wave is absent, or it is very less amount of the carrier wave. So the signal which is appearing like this. Okay. So if there is a 1 means automatically there is no change in the carrier, but 0 means almost all is a very less carrier wave or something, almost it is 0. So sometimes it may be assumed as a negligible value compared with the this amplitude, this will be very negligible. So therefore it is treated as a 0. So again, 2 ones are there. So therefore in this time period, in this complete time period, the wave is again like this. Then 0, again 1, 0, 0, 1. So this is the generally amplitude shift keying signal. Amplitude shift keying signal. So here for 1, the amplitude is more. For 0, amplitude is very lesser value. So that you can just identify. Amplitude shift keying is a modulation method. Amplitude shift keying is a modulation method where digital signals change the amplitude of the carrier wave. Digital signals change the amplitude of the carrier wave. So that is, this is your digital signal. So the output is appearing like this. So that means, suppose if the digital signal is 1, what happens? The digital signal is 0, what happens? That you can observe. So if the digital signal value is 1, then the carrier wave amplitude remains the same. So digital input is high. So for this condition, this type of waveform, there is no change in the carrier wave. So if the digital signal value is 1, then the carrier wave amplitude remains the same. Okay, so that is like, now if it is 0, then what happens? So when the digital signal value is 0, when the digital signal value is 0, the amplitude of carrier wave is much weaker. Much weaker means almost it is equal to 0. So that is this type of waveform. Okay. So this is about the amplitude shift keying. So in the amplitude shift keying, whenever you are attaching your digital information to the carrier wave, if there is a 1 signal applied to the carrier wave, there is no change in the carrier wave, while the 0 signal is applying to the carrier wave, almost all in that particular region, it is carrier signal will become 0. Okay, so that is negligible. So that is the general concept of the amplitude shift keying. Now coming to the frequency shift keying. So in the frequency shift keying, whenever the data value, that is the digital information value is 1, in that particular region, the frequency is higher. The frequency is higher when the bit is present. When the bit is present, the frequency is higher. If the bit is not present, that is 0. For 0 values, almost the frequency is very narrow, that is very lesser frequency. So that is where you have your frequency levels are high. So that is this, you can see frequency shift keying is the digital modulation technique in which frequency of the carrier wave changes with digital signal. So this is about the frequency shift keying. Frequency shift keying is the digital modulation technique. Frequency shift keying is the digital modulation technique in which the frequency of the carrier wave changes with the digital signal. So that means the signal is appearing like this. So this is amplitude shift keying, and here it is. This is the frequency shift keying. The signal appeared in this format because here it is 1. The digital input is high. So this is your digital input. So if the input is high, that is 1, 0, 0. If it is 1, higher the frequency. This is 1, 1. Here also the frequency levels are very high. Here also high. Here also high. Other regions, that is in the 0 regions, almost the frequency is very lesser frequency. This is the frequency shift keying. So the signal, generated signal is in this format. This is the digital modulation frequency shift keying or frequency modulation with by adding the digital information to the carrier wave. Okay. So it is called as a frequency shift keying. So we can see when digital binary value is 1, the frequency of the carrier wave is higher. Okay. In the frequency shift keying, value is high. Value is high. That means binary bit present. The by bit present, the frequency of the carrier wave is higher. This is the general concept. Frequency of the carrier wave is higher. So like this. This is the frequency. 1 is means it is like this. Suppose if it is 0, when binary value is 0, the frequency of the carrier wave would become lower. So binary value is 1, the frequency is higher. The binary value is 0, the frequency of the carrier wave would become lower. Lower means these are the values. This is the value. Here it is. So this is 0. Okay. So in this way, we can identify the frequency shift keying. So frequency shift keying is nothing but the digital data. You can add the digital data to the carrier signal. So in which if the digital bit present, the frequency will be more. If the bit is absent, frequency will be very narrow. So less. Now coming to the, so this is the signal, here it is the carrier. This is the digital information and which is appearing like this. So this is the higher, so we are very closer. So closer means frequency is higher. Here also closer. So closer and closer. So like this, this is the general waveform. Now coming to the phase. So all the 3 types of signals. So this page, in this page, so this is the ASK signal, generated ASK signal. This is the FSK signal. This is the PSK, that is the phase shift keying. That means if there is any change from 1 to 0, so there is any change from 1 to 0, the phase will be changing. So here it is 1. Suppose the signal is in this, carrier signal is in this format, and here there is a change from 1 to 0. So that means instead of moving in this path, suddenly it changes its phase. Suddenly it changes its phase and it starts with a 180 degrees phase difference. So it changes its phase like this. So here this 0, 0, there is no need of any phase change. Again 0, 0, no change of any difference. 0, 0. Okay. But again, this is from 0 to 1. If there is 1 to 0 or 0 to 1, there is a phase change. Okay. All ones are in the one phase. All zeros are in another phase. That is the basic difference in the phase shift key. All zeros are in one phase. All ones are in the another phase. So therefore, this is in this phase. Again, this one, somewhere here one is there. So therefore, it is coming into the same, this phase. So like this. So here, again, one is there. Therefore, there is no need of any phase change there. But here, from 1 to 0. So therefore, here also there is some phase change. So this type of signal will be formed. Okay. There is 1 to 0, 180 degrees phase difference, 1 to 0 or 0 to 1. If the binary values are in the same values, that is 1, 1, 1, no need of any phase change. All zeros, there is no need of any phase change. But if there is 1 to 0 or 0 to 1 transition, 1 to 0 or 0 to 1 change, definitely there is a need of the change in the phase. Okay. There is a need of change in the phase, that is generally called as a phase modulation. Okay. Phase shift keying. So the data transmits, that is the phase transmits data by changing the phase of a constant frequency of the carrier wave. So that is the PSK, phase shift keying, transmits data by changing the phase of a constant frequency of the carrier wave. Okay, so this is the phase shifting. Now the specifically phase changes at the point, phase changes at the point where binary value 1 changes to binary value 0. So phase changes at the point where binary value 1 changes to binary value 0. Similar. So this is the general concept. So here it is 1 to 0 transition, 1 to 0 transition. So this up to this it is one phase, and suddenly here 1 to 0. For 1 to 0, how it changes? This just now we can observe. So for 1 to 0, in this is in this phase, whenever it changes from 1 to 0, there is a sudden phase change like this. So in the broad waveform, which is appearing like this, so this is generally a 180 degrees phase. So instead of moving in this direction, positive moving, it is exactly shifted to the negative. So instead of moving in this direction, it is come to this direction. So here we can define the things also. That is, what is the definition of amplitude shift keying? What is the definition of the frequency shift keying, and also the phase shift keying? Now coming to the definition, in general, the modulation is a process by which some characteristics of a carrier wave is varied in accordance with a modulating, that is a message signal. So modulation is a process by which some characteristics of a carrier wave is varied in accordance with the modulating signal. Now coming to the digital modulation, what is the, we need the digital modulation. So therefore the digital modulation, it is a special kind of modulation. The digital modulation is a special kind of modulation where the message signal, that is the modulating signal, message signal is of digital in nature. So that is in the information is in the form of zeros and ones. So message signal is of digital in nature, that is binary or M-array. Okay, so mission cycle, or that is generally called as the zeros and ones format. It is called as machine language. Sometimes it is called. Therefore, it is M-array encoded version. So the message signal is of digital in nature whenever you are considering a digital modulation. So the digital nature of the carrier wave to be modulated is of usually sinusoidal. To be modulated is of usually sinusoidal. Okay. So that is the digital information attached to the carrier. The resultant wave is, again, it is the analog format only. Okay. Now the digital modulation have three different types of techniques. In digital modulation, switching or keying of the amplitude or frequency or phase of the carrier. So switching or keying of the amplitude, frequency or phase of the carrier wave is used. So here there are three different, that is amplitude modulation, frequency modulation, then phase modulation. They are here in the digital modulation, they are called as ASK, FSK and PSK. The difference is that here the basic difference. The difference is that in digital modulation techniques, ASK, PSK and FSK. The modulating signal is of digital nature. So digital nature, the modulating signal is of digital nature, while in amplitude modulation, phase modulation and frequency modulation, so these three modulations, modulating signal is of analog nature. So that is only the difference. Main difference is in the digital modulation, the signal is in the form of digital signal. In the analog modulation, the signal is in the form of analog signal. So that is the main difference. Okay. Now coming to the definition of amplitude shift keying. So amplitude shift keying, the amplitude of the carrier wave is changed. Amplitude of the carrier wave is changed, that is switched, according to the digital input signal. That is a modulating signal. Therefore, ASK is analogous to the amplitude modulation. So it's like analog modulation. If you are comparing, that is like a amplitude modulation. So this is your carrier wave, and here is your digital data 011001. This is data. This data is added to your carrier signal, carrier wave. So digital input and carrier wave. There is a one signal will present, 0, no signal will present, like this. So here it is 1. So just you can observe. So 1, there is a carrier is as it is present. So here 1 and 1, 2 ones. So single one, it is like this. Other regions, it's very low carrier wave present, almost negligible. So therefore no need of seeing. So here 2, it is lengthy, therefore 2 binary bits. Its length is very less. So this is the amplitude shift keying resultant wave. Amplitude shift keying resultant wave. Now coming to the frequency shift keying. If the frequency of sinusoidal carrier wave, is varied, frequency of sinusoidal carrier wave is varied, that is switched, depending on the digital input signal, then it is known as the frequency shift keying. So there is a change in the frequency. So there is a change in the frequency of the carrier. So therefore that change will be depending on the digital input. Okay. So it is known as the frequency shift keying. It is analogous to the analog. Normally it is compared to the frequency modulation. So here there is a signal. This waveform you can observe in the next slide. Yeah, this. So this is your binary data. This is your carrier signal. That is the sinusoidal carrier wave, high frequency carrier wave. So for one, the frequency is higher, as we discussed earlier. So 1, 1. These two inputs, for these two inputs, the frequency is higher in this region, 2 clock pulses. Then again, for these 2 clock pulses, it is very lower. This clock pulse, here it is 1. The bit value is 1, therefore the frequency is very high. So these two regions, it is very high. This region, very high. Now coming to the phase shift keying. So phase shift keying also we discussed. But here we come to the definition of the phase shift keying. In phase shift keying, phase of the carrier wave, that is the analog, phase of the carrier wave is switched as per the input digital signal. So the carrier wave is switched as per the input digital signal. So this is analogous to the phase modulation. So here it is the binary input. This is your sinusoidal waveform. So here for 0 to 1, there is a phase change. Again, here there is no need of any phase change, but here 1 to 0, there is a phase change. Okay, these two, no phase, no need of any phase change. For 0 to 1, there is a change of phase. So this slide you can see. Okay, so up to this is 0, but 0 to 1, there is a phase change. So that phase, it will start from. So again, the 1, 1, there is no need of any phase change, but here, again, there is a 1 to 0, there is a change of phase. Okay, so that is the phase shift of 180 degrees is required. When there is a change in 1 to 0 or 0 to 1, there is a need of 180 degrees phase change. So this is a phase shift keying waveform. So in this way, we'll discuss about the three different types of digital modulation techniques. Three different types of digital modulation techniques. You have to write in an easy, so you can in a meaningful way you can write it in the exam about the frequency shift keying and phase shift keying. Very important topic. So you have to read it carefully, and I have already posted this PDF file in your WhatsApp group. You can download it, and you have to write it all the points, and also with the neat pictures. The pictorial representation also will give you some good marks. So therefore, these are the two important topics from your second unit. That is the pulse width modulation, pulse position modulation. Then the three types of digital modulation techniques. These are important. If you have any doubts, please ask me your doubts. If you have any doubts, otherwise I will end my today's presentation. If you have any doubts? Okay, if there are.
Sir, thank you.
Okay, Namma. So I think today is the last day to submit your exam forms. So please go to the college and submit your examination forms. Okay. So with this, I will end my today's presentation. Thank you very much for your patient here.